There is something incredibly powerful about small, high-leverage actions, the kind of actions that, once you experience them, fundamentally change the way you approach your day, your energy, and your ability to function at a high level. And today, I want to give you one, just one, but I guarantee if you try it once, you'll want to do it every day. Morning sunlight exposure plays a crucial role in regulating brain chemistry, influencing everything from mood and focus to sleep quality and overall cognitive function. The human brain operates on a finely tuned internal clock known as the circadian rhythm, which dictates when we feel awake, alert, or ready for rest. This rhythm is primarily governed by light exposure, with morning sunlight being the most powerful environmental cue for setting this internal clock correctly. At the core of this process is the suprachiasmatic nucleus, SCN, a small cluster of neurons in the hypothalamus that acts as the body's master timekeeper. When light enters the eyes, it is detected by specialized cells in the retina known as intrinsically photosensitive retinal ganglion cells, IPRGNCs. These cells are not involved in vision, but instead send direct signals to the SCN, which then orchestrates a cascade of neurochemical changes throughout the body. One of the first responses to morning light exposure is the controlled release of cortisol. While cortisol is often thought of as a stress hormone, its proper regulation is essential for energy, alertness, and immune function. A well-timed cortisol pulse in the morning helps signal wakefulness, increases metabolism, and primes the body for activity. Unlike stress-induced cortisol spikes, which can be harmful, this natural morning surge plays a beneficial role in synchronizing various physiological processes. Simultaneously, exposure to natural light triggers a release of dopamine, a neurotransmitter associated with motivation, pleasure, and goal-directed behavior. When dopamine levels rise in response to morning light, it enhances mood, increases drive, and promotes a greater sense of engagement with tasks. This is why individuals who consistently expose themselves to morning sunlight often report feeling more focused, motivated, and mentally clear throughout the day. Another key effect of morning sunlight exposure is its role in regulating melatonin, the hormone responsible for sleep. Melatonin is produced by the pineal gland and is crucial for initiating and maintaining sleep. However, its release is not random. It follows a tightly controlled cycle influenced by light. When the SCN receives input from the IPRGCs in the morning, it essentially acts as a reset button for melatonin production, suppressing it during daylight hours and initiating a precise countdown for its release later in the evening. This process ensures that melatonin secretion begins approximately 12 to 14 hours after morning light exposure, aligning sleep with the natural night cycle. The quality and intensity of morning light are also critical factors in this process. Natural sunlight, even on a cloudy day, provides a significantly higher intensity of light compared to indoor artificial lighting. The lux measurement, which quantifies light intensity, demonstrates this stark difference. Indoor lighting typically ranges from 100 to 500 lux, whereas outdoor sunlight can easily exceed 10,000 lux in the morning and even reach 100,000 lux at midday. This intensity matters because the IPRGCs require a strong light signal to effectively regulate circadian rhythms and neurochemical responses. Artificial lighting, no matter how bright it may seem indoors, is insufficient to fully activate these pathways. Another crucial aspect of morning light exposure is its impact on serotonin levels, which are closely linked to mood and emotional well-being. Serotonin, often referred to as the happiness neurotransmitter, plays a dual role in both mood stabilization and sleep regulation. Morning sunlight stimulates serotonin production, which not only contributes to feelings of well-being during the day, but also serves as a precursor for melatonin synthesis at night. In other words, the more natural light the brain receives in the morning, the more efficiently it can produce melatonin later, reinforcing a healthy sleep-wake cycle. The timing of light exposure is equally important. The first 30 to 60 minutes after waking are the most effective window for receiving these benefits, as this is when the brain is particularly sensitive to environmental cues that regulate circadian rhythms. Delayed exposure, such as staying indoors for extended periods after waking, can disrupt this natural cycle, leading to sluggishness, mood instability, and difficulties with sleep later in the evening. The earlier the brain receives a strong light signal, the more effectively it can set the body's internal clock for optimal performance. When the body is exposed to morning sunlight, a precise biological timer is set that determines the release of melatonin, the hormone responsible for sleep. Melatonin is produced by the pineal gland and plays a critical role in regulating the body's sleep-wake cycle. Unlike neurotransmitters such as dopamine or serotonin, which have multiple functions throughout the day, melatonin operates almost exclusively in the evening and night, preparing the body for rest. However, its production is not constant or automatic. It follows a tightly regulated schedule, influenced by external cues, with light exposure being the most significant factor in controlling when and how much melatonin is released. When natural light enters the eyes in the morning, specialized cells in the retina called intrinsically photosensitive retinal ganglion cells, Ippergene Cs, detect the presence of light, particularly in the blue wavelength spectrum. These cells send direct signals to the suprachiasmatic nucleus, SCN, the master circadian clock located in the hypothalamus. The SCN processes this information and relays instructions to the pineal gland, signaling that it is daytime and that melatonin production should remain suppressed. This suppression is essential for wakefulness, focus, and energy levels throughout the day. At the same time, the SCN sets a precise countdown timer for melatonin secretion, typically initiating its release 12 to 14 hours later. This mechanism ensures that the body's sleep drive aligns with the natural night cycle. The delayed onset of melatonin allows for an extended period of alertness and productivity during the day while promoting sleepiness at the appropriate time in the evening. Individuals who receive sufficient morning light exposure consistently experience an easier transition into sleep at night, falling asleep faster and achieving deeper, more restorative rest. 3. The predictability of melatonin release also enhances the overall stability of the circadian rhythm, reinforcing a healthy sleep-wake pattern over time. The strength of this biological timer depends on the intensity and duration of morning light exposure. Natural sunlight provides the optimal light signal as it delivers significantly higher lux levels compared to artificial indoor lighting. Even on overcast days, outdoor light can reach 10,000 lux or more, whereas typical indoor lighting ranges between 100 to 500 lux, which is insufficient to trigger the full biological response. Direct exposure without sunglasses or window barriers is most effective in sending a strong signal to the SCN, ensuring that the melatonin countdown is accurately set. Inconsistent light exposure can lead to disruptions in this process, causing misalignment between the body's internal clock and external time cues. Late or insufficient morning light can delay melatonin production, making it more difficult to fall asleep at night and leading to grogginess upon waking. Conversely, exposure to artificial light at night, particularly from screens or overhead lighting, can interfere with melatonin secretion, reducing its effectiveness in promoting deep sleep. These disruptions contribute to fragmented sleep, increased fatigue, and difficulty maintaining consistent energy levels throughout the day. The relationship between light exposure and melatonin timing extends beyond just sleep. It also affects mood regulation, metabolism, and overall cognitive performance. When melatonin is released at the correct time each evening, the body undergoes critical physiological processes, including cellular repair, memory consolidation, and hormonal balance. The consistency of this release is essential for long-term health, as irregular sleep-wake cycles have been linked to increased risk of metabolic disorders, mood imbalances, and cognitive decline. Morning sunlight exposure has a profound impact on focus and mood throughout the day, largely due to its ability to regulate the release of key neurotransmitters. One of the most significant effects is the stimulation of dopamine, a chemical that plays a central role in motivation, attention, and overall cognitive function. Dopamine is often associated with reward-seeking behavior, but its influence extends far beyond that. It enhances mental clarity, improves problem-solving abilities, and increases the drive to engage in goal-directed activities. When sunlight enters the eyes in the morning, it triggers a cascade of neural signals that lead to increased dopamine production in the brain, particularly in areas like the striatum and prefrontal cortex, which are responsible for motivation and executive function. This is why individuals who receive consistent morning light exposure often report feeling more energized, focused, and mentally sharp throughout the day. Beyond dopamine, another major player influenced by morning sunlight is serotonin. Serotonin is a neurotransmitter that regulates mood, emotional stability, and a sense of well-being. Low serotonin levels have been linked to feelings of depression, anxiety, and fatigue, while higher levels contribute to a more positive, resilient mental state. Exposure to natural light in the morning stimulates serotonin production in the raphe nuclei of the brainstem, leading to an increase in mood and a reduction in stress levels. Additionally, serotonin serves as a precursor to melatonin, meaning that the more efficiently serotonin is produced during the day, the more effectively melatonin can be synthesized at night, reinforcing a healthy sleep-wake cycle. Cortisol, often referred to as the stress hormone, is another critical factor influenced by morning light exposure. While cortisol is typically associated with the body's response to stress, it also plays an essential role in regulating alertness and energy levels. A properly timed cortisol pulse in the morning helps activate the body's metabolic processes, increase blood circulation, and enhance cognitive performance. This natural rise in cortisol, known as the cortisol awakening response, is most effectively triggered by exposure to bright light in the early hours of the day. When this process is aligned with the body's circadian rhythm, cortisol levels gradually decrease throughout the day, preventing excessive stress buildup and promoting a more balanced emotional state. Light exposure also has a direct impact on the autonomic nervous system, which controls the balance between the sympathetic, fight or flight, and parasympathetic responses. Morning light helps establish a stable equilibrium between these systems, preventing excessive activation of stress pathways while ensuring sufficient arousal for peak cognitive function. This balance is crucial for maintaining steady energy levels, reducing mental fatigue, and improving resilience to daily challenges. Individuals who lack exposure to natural light in the morning often experience sluggishness, mood instability, and difficulty concentrating as their neurochemical rhythms become misaligned. The timing of light exposure plays a key role in determining its effectiveness. Receiving natural light within the first 30 to 60 minutes of waking provides the strongest signal to the brain, setting the stage for optimal neurotransmitter production and circadian alignment. Delaying light exposure or relying solely on artificial lighting indoors diminishes these effects and can lead to suboptimal mental performance. The intensity and quality of light also matter, as natural sunlight provides a much stronger stimulus compared to artificial sources, ensuring that the necessary neurochemical responses are fully activated. Morning sunlight exposure requires only 5 to 10 minutes outdoors to produce significant physiological and neurological benefits. This brief but powerful interaction with natural light activates a series of processes that optimize energy levels, cognitive function, and sleep regulation. The key to its effectiveness lies in the quality and intensity of the light received, as natural sunlight provides a much stronger signal to the brain than artificial indoor lighting. Even on overcast days, the intensity of outdoor light far exceeds what is available indoors, making it essential to step outside to maximize the benefits. When natural light enters the eyes, specialized retinal cells called intrinsically photosensitive retinal ganglion cells, IPSCs, detect specific wavelengths of light, particularly those in the blue spectrum. These cells send signals directly to the suprachiasmatic nucleus, SCN, the body's master circadian clock located in the hypothalamus. This interaction triggers a well-coordinated sequence of hormonal and neurochemical changes designed to promote wakefulness, alertness, and overall well-being. The SCN, in response to light exposure, initiates a suppression of melatonin, the hormone responsible for sleep. At the same time, it sets a biological timer that determines when melatonin will be released later in the evening, ensuring that the sleep-wake cycle remains aligned with natural light-dark patterns. Beyond melatonin regulation, morning light exposure rapidly increases dopamine levels, a neurotransmitter associated with motivation, focus, and goal-directed behavior. Dopamine release in response to bright light occurs in areas of the brain, such as the striatum and prefrontal cortex, which are critical for executive function and decision-making. This increase in dopamine leads to greater mental clarity, improved mood, and enhanced cognitive performance throughout the day. Additionally, serotonin production is stimulated by morning light, further contributing to a sense of well-being and emotional stability. Since serotonin serves as a precursor to melatonin, exposure to natural light in the morning not only improves mood during the day, but also ensures more efficient melatonin synthesis at night, reinforcing a stable sleep-wake cycle. Cortisol, another key hormone influenced by morning light, follows a natural daily rhythm that is optimized by exposure to sunlight shortly after waking. The cortisol awakening response, which provides a healthy surge of energy in the morning, is amplified when bright light is detected by the SCN. This increase in cortisol is essential for activating metabolic processes, improving immune function, and maintaining stable energy levels throughout the day. Importantly, proper morning light exposure helps regulate cortisol release, preventing excessive spikes that can lead to stress and anxiety, while ensuring that levels gradually decline in the evening, facilitating relaxation and sleep preparation. The effectiveness of morning light exposure depends on both intensity and duration. Spending just 5 to 10 minutes outdoors provides a sufficient light signal to trigger these biological responses, particularly when the sky is clear on cloudy days. Slightly longer exposure may be necessary to achieve the same effects, but the overall requirement remains minimal. Unlike artificial lighting, which lacks the necessary brightness and spectral composition to fully activate the GCs, natural sunlight delivers the optimal stimulus for setting the body's internal clock and optimizing neurochemical balance. Biological leverage is one of the most effective ways to improve daily function, and morning sunlight exposure is a prime example of a natural stimulus that requires no effort to maintain once experienced. Unlike habits that rely on willpower or motivation, light exposure works directly with the body's existing neurobiology to create a self-reinforcing cycle of benefits. When the body receives bright natural light in the early part of the day, it sets off a chain of physiological events that enhance wakefulness, mood, focus, and sleep quality. These effects are noticeable almost immediately, making it easy to continue the practice without requiring external reminders or discipline. One of the primary reasons morning sunlight becomes self-sustaining is its impact on dopamine levels. Dopamine is the neurotransmitter most associated with motivation and reinforcement, meaning that when an activity triggers its release, the brain naturally seeks to repeat that behavior. Exposure to sunlight in the morning stimulates dopamine production in key brain regions like the prefrontal cortex and striatum, leading to increased energy, improved mood, and heightened cognitive function. The positive feeling created by this dopamine release makes morning light exposure a rewarding experience, reinforcing the desire to step outside each day. The effect on sleep quality further solidifies this cycle. When the eyes detect bright light early in the day, the suprachiasmatic nucleus, SCN, in the hypothalamus adjusts the circadian clock to ensure that melatonin, the hormone responsible for sleep, is released at the correct time in the evening. As a result, individuals who consistently get morning light find it easier to fall asleep and stay asleep. High-quality sleep leads to better mood, greater energy, and improved cognitive performance the following day, increasing the likelihood of repeating the habit. Over time, the brain and body become naturally attuned to this rhythm, making it an automatic part of the daily routine. Cortisol regulation also plays a role in making this practice effortless. Cortisol follows a natural daily rhythm, with levels peaking in the morning to promote alertness and gradually declining throughout the day. Morning sunlight exposure helps regulate this cortisol pulse, ensuring that energy levels remain stable and stress levels stay manageable. This proper timing prevents mid-afternoon crashes and excessive evening alertness, further reinforcing the natural pattern of wakefulness and rest. When individuals experience the benefits of balanced cortisol levels, they are less likely to disrupt their rhythm with artificial light at night or stimulants throughout the day. Another factor contributing to the self-reinforcing nature of morning light exposure is its impact on serotonin, a neurotransmitter crucial for mood regulation. Higher serotonin levels, stimulated by sunlight exposure, lead to a greater sense of well-being and emotional stability. Since serotonin is also a precursor to melatonin, consistent morning light exposure directly enhances sleep quality, further strengthening the cycle of benefits. Over time, as individuals experience more consistent energy, improved mood, and better sleep, the need to force the habit disappears. The body naturally seeks out the stimulus that keeps it functioning optimally, making morning light exposure an action that requires no effort to maintain once the benefits are felt. Trying morning sunlight exposure once is often enough to experience its immediate and powerful effects, making it an easy behavior to repeat daily. The body's response to natural light is hardwired into its biology, meaning that the benefits begin the moment sunlight enters the eyes. This direct impact on wakefulness, mood, and focus makes it an instantly reinforcing habit. Unlike routines that require effort or delayed gratification, the effects of morning light are noticeable within minutes, providing an immediate sense of alertness and mental clarity. One of the first noticeable effects is a rapid shift in energy levels. Morning light exposure triggers the suppression of melatonin, the hormone responsible for sleep, while simultaneously increasing cortisol in a controlled manner. This natural rise in cortisol is distinct from stress-induced cortisol spikes, as it helps activate the body's metabolic processes, improve circulation, and prime the brain for focused activity. The result is an immediate reduction in grogginess and a smoother transition into wakefulness, making it easier to start the day with a sense of purpose and clarity. This heightened alertness becomes something the brain craves, reinforcing the desire to repeat the behavior each morning. Dopamine release further enhances this self-reinforcing effect. Exposure to bright sunlight in the early hours of the day increases dopamine levels in brain regions associated with motivation, goal setting, and pleasure. This neurotransmitter not only drives productivity, but also creates a feeling of reward that makes the behavior more likely to continue. Once a person experiences the improved mood and mental clarity that come with morning light, they are naturally inclined to seek it out again the next day. Unlike habits that require discipline, the brain itself pushes for repetition due to the positive neurochemical response. The impact on sleep is another reason why morning light exposure quickly becomes a daily practice. When bright light enters the eyes early in the day, it sets a precise timer for melatonin release later in the evening, ensuring that sleep occurs at the right time. Individuals who experience deeper and more restorative sleep as a result of morning light find that they wake up feeling more refreshed, creating a cycle of consistent energy and well-being. This direct improvement in sleep quality makes the habit easy to sustain, as the benefits are both immediate and long-term. Serotonin, another key neurotransmitter influenced by light exposure, plays a significant role in stabilizing mood and reducing stress. Morning sunlight stimulates serotonin production, leading to a greater sense of well-being throughout the day. Since serotonin also serves as a precursor to melatonin, its presence in the morning ensures better sleep at night, reinforcing the cycle. The combination of enhanced mood, improved focus, and better sleep creates a loop that requires no external motivation to maintain. The simplicity of the practice is what makes it so effective. It does not require special equipment, supplements, or a major time commitment. Stepping outside for just a few minutes each morning delivers all the necessary benefits, and once someone experiences the difference it makes, it becomes an automatic part of the daily routine. The ease of access combined with the powerful physiological effects makes morning light exposure one of the simplest yet most effective behaviors for optimizing mental and physical health.